rational. All right, so page 1. You ready for it, or are you still looking? Or working?
No, I'm ready.
Ready? Okay. So this first one here, what we would do is first you want to multiply everything by the least common denominator, which is x minus 1. So it goes here, here, and here, right? You're multiplying basically both sides of it, right? When it goes here, what happens to it? When it goes to this term, what happens to the x minus 1?
It gets canceled out.
Right? So you just have 2x left over, right?
Mhm.
Plus x times x minus 1, nothing to cancel out there, equals, same thing here, it just cancels out, right?
Mhm.
So there's your equation. And now notice we just have a quadratic equation. So 2x plus x squared
Squared.
minus x equals 3 minus x. Move it all over to the left side. So that's going to be x squared plus x equals 3 minus x. Add x to both sides, x squared plus 2x minus 3 equals 0. I subtracted 3. Got it?
Hmm.
I can factor that, take an x out, and this is a positive 3 and a negative 1. Good with that?
Yeah.
Which means x equals negative 3 or x equals positive 1. But now you have to check, go plug them back in up to the top, and you'll notice you can't plug in 1 because it would
Hmm.
give the denominator of 0.
0. Okay.
And just check to make sure, just for the sake of, you remember how to use your store button on here?
Yes.
-3 store for x, and then if you're allowed to use your calculator, which you may not be able to, 2x divided by, just be careful when you're writing this, x minus 1, hit enter, and then add x to that, hit enter, and that should be the same thing. So -1.5 should be the same thing as the right side, which is 3 minus x divided by x minus 1, which it is.
Okay. So the x equals 1 would be an extraneous solution,
Correct.
right?
Yep. That's extraneous. Yep. This next one, we're just simplifying this then, I take it.
Yeah.
Okay, so see if these factor. So this is going to be x minus 4 and x plus 3. You good with that?
Hmm.
And this is probably going to be x minus 4. You know why I know it's probably going to be x minus 4?
Because it's a.
Because I
Oh,
already have
yeah,
one.
yeah, yeah.
And I can't have an x plus 3 because 3 isn't a factor of 8. So I just didn't know how these problems work. Usually they have one factor in common. Sure enough, x minus 4 times x minus 2. So that's what my equation is, right? It's
Mhm.
7 over that or 2 over that. So now what I'm going to do is multiply the so let me just rewrite this down here. 7 over x minus 4 times x plus 3 minus 2 over x minus 4 times x minus 2. So you can see you're going to have to get that x plus 3 into here. So you have to multiply that on the top and the bottom. So you have x
Okay.
plus 3 there. And you need that x minus 2. You need that to be here. So in order for it to be on the bottom, you also need it on the top.
Okay.
Got it?
Yeah.
And then you will simplify that. So multiplying that out, you get 7x minus 14 minus, now be careful with this, that negative, people forget to distribute this in. So it's going to be minus 2x minus 6, because that negative has to go with the 2 into the parentheses there.
Oh,
You know
okay.
what I'm talking about? That's the
Okay.
mistake most people make, one of the mistakes they make. So there's my common denominator. And now I can just simplify that into 5x minus 20 all over x minus 4 times x minus 2 times x plus 3.
Okay.
And then you might want to factor out that, just to be safe, hey, look what happens. When I factor out that 5, out of
Yeah,
that, I actually see that I can cancel out another factor. That x minus 4 can cancel out. So this can simplify to 5 over x minus 2 times x plus 3. But when you do that, you'll have to write also that x cannot equal 4. Because whenever you cancel something out, you have to account for that in your domain. Notice I don't really have to account for the 2 and the negative 3 because that I can still see that x can't equal that. But by just looking at this, I don't realize that I'm really not allowed to plug in 4 because I had canceled it out earlier. See, way at the beginning, 4 was not part of the domain, so you're not allowed to plug that in. 4, 2, and negative 3, none of those are part of the domain for your expression. But when you simplify it, it looks like 4 is part of the domain, but remember it's not, because that's where it came from. Make sense?
Yeah.
Next one. All right, now we're graphing. So let me insert a graph real quick here. Graph paper. All right. So let's just go ahead and write out what we have over here. I'll do this just kind of quick. First, if I factor the top, the bottom's already factored. But if I factor the top, I can see that I'm going to have a removable discontinuity with whatever I cancel. So the whole is going to be at -1. Do you see why it's at -1?
Because you took that out.
Yeah, because that's what I canceled. And now plug -1 into the remaining part of the equation. So -1 minus 1 is -2 over -1 minus 3 is -4 squared is positive 16. So -2 over 16, which is -1/8. So there's my whole. I've got a whole at -1/8. So I'm going to draw my graph out here. There's my x-axis. There's my y-axis. I've got a whole at -1 comma -1/8. So there's a hole right here.
Okay. That's why I was kind of confused because I didn't think they would give that as a whole.
No, yeah, it can be an irrational number, to be honest. It can be anything. But yeah, let me make this a little thicker. Okay. So that was the first step. Okay. Next step is a horizontal asymptote. You find that by looking at the degrees of the numerator and the denominator. You can see that the degree of the denominator is bigger than the degree of the numerator. That means that the horizontal asymptote is your x-axis, which is y equals 0. So your horizontal asymptote is right here.
How do you figure that out?
The degree of the numerator and the denominator. If the degree of the numerator, which is 1 right now, right?
Mm-hmm.
Your simplified expression is just x minus 1 all over x minus 3 squared. So whenever it's bottom heavy, when the degree is bigger on the bottom than it is on the top, that means the vertical asymptote or horizontal asymptote is your x-axis, which is the line y equals 0. Okay. If the degrees were the same, the degree of the top and the bottom were the same, then the vertical asymptote would be the ratio of leading coefficients in the front. For example, if your equation like 3x plus 2 over 5x minus 1, your vertical asymptote for this would be 3/5. The line y equals 3/5.
All right.
If the degree of the top is bigger than the bottom, like let's say this is squared, then there is no horizontal asymptote. There's a slant asymptote, but I don't think you need to worry about that yet.
Okay.
I don't think you're doing that, right?
Yeah, no, we're not doing that yet.
You just have to say none for horizontal asymptote in that case. Okay. So if this denominator was a degree of 3, you see how the degree in the denominator is bigger than the numerator?
Yeah.
That means that the line y equals 0 is your horizontal asymptote, just like our example here.
Okay.
If the degrees are the same, let's say that this was still 3. then doesn't matter what they are, as if the degrees are the same, doesn't matter how big they are or small, as long as they're the same degree, then the leading coefficients is the asymptote y equals 3/5.
Okay.
When you get to calculus, you'll kind of deal with that more and you'll understand why in a better way. But for now, just know it. Vertical asymptote has to do with the denominator. You set the denominator equal to 0, and so we do that. We get x equals 3. So x equals 3 is my vertical asymptote. So it's right here. And now, do you remember about multiplicity of asymptotes?
No.
The fact that the multiplicity is 2, I'm going to just write that down here so you can understand. Some teachers don't explain this. But multiplicity 2, that means that it's going to approach, your graph is going to approach it in the same direction on either side of that asymptote. So if one side goes up, the other side is going to go up as well. If the degree was odd, it would approach it in opposite directions like that. It's just a good thing to know. I'll show you why in a second. The x-intercepts in this case are where the numerator equals 0, which is just x equals 1. So I'm not going to write x equals 1. I'm going to write 1, 0. Okay, so you don't think it's a line. So 1, 0 is my x-intercept. There it is in blue. Got it?
Mm-hmm.
That's my x-intercept, which is kind of interesting. And then y-intercepts are nice to find. Y-intercepts are nice to find as well. So plug in 0, and you'll get 1. You'll get 0. You plug in 0 for x, and you're going to get -1 over +9. So -1/9, which checks out because look at my graph over here. Do you see where this is going? Can you see what's going to happen? Look at the 3 points that I have. They're all like really close to each other.
They're gonna rise.
So what happens is it's going to go up like this. It's going to approach that way. It's not going to bounce off of this and go down. And you see how this is below it. So it's got to approach it, but then it's going to actually approach. It's going to come back up and approach this x-axis right here, because that's what an asymptote is.
Yeah, it's like a line you cannot cross.
Mm-hmm. Yep. But on the right side of the graph, you see, I know because of this little trick I taught you here, I know I don't have to even plug in a point. I know the graph has to be going this way.
Okay.
Now, it wouldn't be a bad idea just to plot a point, like to plot 4. Plug in 4 and you'll get a number. You'll probably get 2 or something like that, or 1. Plug in 4. 4 minus 1 is 3. 3 over 1, which is 3. So if you plug in 4, you get 3. So that can show you as well. If you plug in 5, you're going to get 2 over 4, which is 1/2. If you plug in 5, you'll get 1/2. So that's what the graph. It's not horrible to just quickly plug in a couple points, but I know that that's what it has to look like. And your teacher doesn't need it to be perfect like that.
We just kind of have to guess draw it. We only
yeah. Okay, you understand how that works?
Yeah, I get that one.
All right. So what do you think we're gonna do for this one?
You're gonna wait. Didn't we already do this one?
No.
Oh no, we didn't. Okay, so you are gonna first start by factoring out the bottom, the denominator on the right side.
Good. And guess what? I'm thinking it's probably going to be that times that.
Or yeah.
I'm guessing. Let's see. Let's guess and check it. Hey, look, that worked. How about that? How strange. No, it's really not strange. That's just how usually it happens. So this one is going to need an x. Actually, you know what? I'm not going to do it that way. I'm going to show you the way I prefer to do it, which is called clearing the fraction. Have you ever learned that?
No.
So some teachers want to show you how to get common denominators, right? And kind of keep the denominator, and that's fine. That'll work. Sometimes you have to do that if it's not an equation. But when it's an equation, there's an easier way to deal with this, and it's called clearing the fraction.
Okay.
So I'm going to multiply this entire equation by that least common denominator, just like I did before. And when I multiply it here, what happens? What's going to cancel out?
Everything, basically.
Yeah, everything's going to cancel out. So I'm just going to be left with the 12, right?
Yeah.
And when I multiply it here, what's going to cancel out?
The x plus 4.
Right? And you're going to be left with an x minus 2 on the top. Follow?
Mm-hmm.
And when I multiply it, what color am I using? Yeah, green. When I multiply it here, what's going to cancel out?
The x minus 2.
Yep. And so you're just going to have an x plus 4 left. That's going to be multiplying what's up there, which is an x. Okay. So you see how simple that was? I cleared my fraction, and now I've got a very simple quadratic equation. I can distribute that in, add it together, subtract the 12 over while I'm at it. So x squared plus 5x minus 14 equals 0. And that's just going to be 7 and 2, positive 7 and negative 2. X equals negative 7 and x equals positive 2. And check your answers. Which one is extraneous, or are either of them? 2 is extraneous, so see you later. And negative 7 probably works if you plug it in with that store method I said. You'll probably find out that it works. So x equals negative 7 is your answer.
Okay. Okay.
Got it?
Yeah.
All right. So we're graphing again. I'm just going to go through that same process that I did before. So factoring this out, it's going to be, I'm guessing it's going to be an x minus 3 and an x minus 2. The reason I'm guessing that is because I'm betting there's going to be a hole. And sure enough, that works. If you FOIL this back out, you'll see that that is equal to this, right? So that means I can cancel out that x minus 3. So really, this is just x minus 1 over x minus 2. That's really what this expression is. But there's a hole at 3, comma 1. Got how I did that?
Not really.
So I plugged in 3. See how that, remember I canceled that out. So
yeah,
x equals x minus 3. So you understand how I got the 3?
Yeah, I understand how you got the 3.
So to get the 1, you just plug the 3 in for any x's back over.
Okay, that's right. Okay.
So 3 minus 2 is 1. 1 over 1 is 1.
Okay.
Horizontal asymptote, because it's bottom heavy, what's the horizontal asymptote?
It would be no. Would it be none?
Y equals 0. Oh, no, yeah. When it's bottom heavy, see how the denominator has a bigger degree? If the degree of the denominator is 1, the degree of the numerator is 0. So it has a bigger denominator on the bottom. And when that happens, the vertical or horizontal asymptote is the x-axis, y equals 0.
Okay.
What's my vertical asymptote?
You're 2.
X equals 2. Good. What's my x-intercept?
There would be none. Yeah.
And what's my y-intercept? Plug in 0 for x.
Oh yeah, it'd be 0 1/3.
1/2.
1/2.
Negative 1/2. Got it?
Oh, okay. Yeah.
You see how that works?
Yeah. I just didn't see a negative.
Yeah. Okay. So let's graph it now. So there's my x-axis. There's my y-axis. My hole is at 3, comma 1. There's a hole. My horizontal asymptote is the x-axis. My vertical asymptote is x equals 2. And what's the multiplicity of that vertical asymptote?
2, right? Or no. None.
1. The multiplicity is 1, which means it's going to approach in opposite directions. So, and my y-intercept is 0, comma, -1/2. So I have all the information I need. It's got to be going like this and like this, and it has to be going like this and like this.
Okay.
See why it goes on opposites? It's approaching from opposite directions because the multiplicity of your VASI is 1. Because there's only 1 here. There's not
Okay.
a 2. There's not like a squared like in the last one.
Yeah. Okay.
Got it? You want to throw another one out there?
Yeah, let me grab one. Okay, I got it.
All right. So this is a, oops. Make that bigger. I have a band-aid on my thumb, so I can't use my thumb to make it bigger. All right. So this is a simplify problem, right? Simplify.
Yeah.
So what you're going to have to do is multiply the top and bottom by the thing that it's lacking. So that one's lacking in x plus 3, and this one's lacking in x minus 3.
Okay.
Got it? So then I have 2x times x minus 3 plus x plus 3 times x minus 3 all over x plus 3 times x minus 3. Now you remember x plus 3 times x minus 3 just equals x squared plus or minus 9. Remember that?
But wouldn't the x plus 3 and the x minus 3 cancel out?
No. No, because this is being added to something up here. So you have to add it. So this is 2x squared minus 6x plus that. So really this is equal to 3x squared minus 6x minus 9 all over x squared minus 9.
Okay.
And now you see, oh wait, I can factor out a 3. So when I factor out a 3 up here, I'm left with an x squared minus 2x minus 3. Oh, and that factors some more, doesn't it? So that's x minus 3 and x plus 1. Well, I better factor that back out. Again, I shouldn't multiply those together because what can I do now with that x minus 3?
You can cancel it out.
Yeah, that's gone. So really this just simplifies to 3 times x plus 1 all over x plus 3, but I should really technically write what? X can't equal.
X can't equal -3.
No, x can't equal 3. It also can't equal -3, but you can see that here. It can't equal 3. I have to say 3. You can say or -3 if you want, but you can tell that x can't equal -3 here, right?
Yeah.
Because that's still there. What you can't see in this equation is that this was canceled out. So originally, look at this problem. Or obviously, what can you not plug in for x?
3 or -3.
3 or -3, right?
Okay.
Okay.
All right.
Let's find another one.
Yeah, it's just keep talking. Same one. Uploaded it.
All right. What are you going to do first for this one?
You are going to factor out the bottom, the denominator
And what do you get when you factor it out?
When you factor out the first one, you would get 1 and 6. So -1 and -6, yeah. And then for the second one, you get -2 and -3. Or positive. No, no, -2. Wait, what?
Nope. That doesn't work. Try again. Remember what I told you?
Oh, it's 1 and
Usually it's gonna one of the
okay, it's gonna be the same thing. But it'd be -6
no,
positive.
not there you go. Okay, so what am I gonna have to multiply this by? I'm gonna have to add the x plus 1 on the bottom and the top, right?
Yeah,
And for this one,
x minus 1.
x minus 1 on the bottom and on the top. So this equals x times x plus 1 minus, be careful with that minus, x times x minus 1 all over this whole mess. And let's not multiply it out. Let's just leave it. Got it?
Yeah.
Now simplify that. So what's that going to be distributed? Tell me what to write. I'll let you tell me.
So you would, can you cancel? No, you can't. Wait, so hold on. Why can't you cancel out the x minus 1? Like once you have those up top?
This one and this one?
Yeah.
Because is this a factor of the entire numerator? Why would you be allowed to cancel this with this? Here, think of it like this. Look in the upper right. If I had 3 plus 5 over 5, can I cancel those 5s out?
No,
Why not?
because it would end you up with 0.
It would end up with 3 plus 1, which is 4. Does that equal 4? Is 3 plus 5 over 5 equal to 4? Of course not. You can't do that because that's not how it works. Because this 5 isn't only dividing this 5, it's also dividing the 3. So you can't just cancel it with that because then you're not putting that 5 in with the 3 also.
Okay.
You're not distributing it. So look at what you're doing here. You see how these are separate. You see how these aren't. This isn't a factor of the top.
Okay.
If this was here and here, you could cancel them out because
Okay.
this would be a factor of the numerator, but it's not. So you have to actually simplify this whole mess and then try to factor it, cancel it out.
So you would distribute the x's on both sides.
Correct.
And so you would get -x.
X squared plus x minus x squared plus x all over x plus 1, x minus 6, x minus 1. Now what is that? What happens to that?
Can't you, wouldn't it just end up as being 2x?
Good. 2x on the top. And what about on the bottom?
It would still be the same.
Yeah. Got it. And you don't really have to write anything in this case because you can see everything. You didn't cancel anything out, so you don't have to put a provision in there about what the domain can't be equal to. Okay.
All right.
So for this one, again, since this is an equation, what would be better for you to do? What would be wiser and easier? Multiply the entire thing by
3y.
3y. This is again called clearing the fraction. CTF, clear the fraction. So when I distribute this into this term, what cancels out and what am I left with?
You cancel out when you just have, you'd cancel out the 3, and when you cancel out both denominators on the left side.
Yep. So what would you have?
3y.
No, you'd have 7 because you canceled out the 3y's. You'd have 7.
Oh, yeah. Okay.
Understand that?
Oh, yeah,
What would cancel out when you multiplied it here?
the 3.
And you just have 1y left, right? Do I have to write the 1?
No,
No, don't have to write the 1. And what would happen? What would cancel out when you multiplied it there?
the y.
And so what would you be left with?
Uh, 8y.
8 times 3. Nope, because the y's canceled, right? You just said the y's
Oh, yeah,
canceled.
yeah. So it'd be 8 times 3. Okay.
Got it. So that's
Yeah.
24 plus y equals 7, which means y equals subtract 7 from both sides. And you get 17. No, sorry, negative 17. Correct?
Mhm.
So 24 minus 17 equals 7. That is correct. So if you plug it in, again, I'll just show you this cool little trick. Negative 17, store it for x, hit enter, and then type in 8 divided by x plus 1/3, and then type in 7 divided by 3x, use parentheses just to be safe. Should get the same answer, and you do. Got it?
Yeah.
So that was the answer. What should I do for this one?
Can you clear the fraction on this one? Or is there,
Yep. Again,
should
anytime,
we,
yep, anytime it's there's an equation, instead of dealing with the fractions, just get rid of them. Clear them out.
okay. So you would
How
get
am
rid
I
of
multiplying by?
7
No.
or
What am
p.
I multiplying everything by? P and P plus 3. So you want to
Okay.
multiply it by the least common denominator of all the fractions, or all the
Okay.
denominators. So it's P and P minus 3. Why? Why am I doing that? Because now look what happens when I multiply it here. I'm going to get 7 times P plus 3, right? When I
Mhm.
multiply it here, what cancels out?
The 7p. Or no,
No,
no. The p. The p plus
the
3 would cancel out.
the P plus 3, and what's still there then?
The
Just the
remaining
P.
p. Yeah.
Just the P. So it's P times 7P minus 9. Do you understand that?
Yeah.
And what stays here if I multiply that over to here? What gets canceled, I should say?
P.
The P's get canceled, and what stays behind?
15p plus 3.
You get that?
Yeah.
And now you just have a quadratic that you can just deal with and be done. Right? So you don't have to worry. It's called clearing the fractions. It's nice because people don't like dealing with fractions, so clear them, get rid of them. And the
Mhm.
only time you're going to have to deal with the fraction is maybe at the very end when you're solving the equation, or when you're solving after you factor, but you don't have to deal with it right now. You're just dealing with a regular polynomial. So 7p squared minus 9p equals 7p squared plus 21. Notice how nice this is. The 7p squareds cancel out. So this actually isn't a quadratic. This is just a linear equation. Got it? Because the only quadratics
Okay.
cancel out. And that happens sometimes, which is great. When that happens, it just means you only have one answer, which is nice. So 6p plus 45 equals 21. So
And then you would just
6p,
move 21 to the other side.
no, I would move 45 to the other side. So negative 24. Because
Oh,
remember,
yeah,
when
yeah, yeah.
the linear, you just have to isolate the p,
Yeah.
isolate the
I was
variable.
thinking of it as a quadratic.
Right. Yeah, you don't have to set it equal to 0 when it's linear.
Yeah.
So p equals -4 is your answer. And then check to make sure it works. Does -4 work here and here? Again, use your store button. -4, store it for x. If they allow you to have a calculator with you. 15 divided by x plus 7x minus 9 divided by x plus 3, and my answer should be 7. That's not good. What I do wrong here? Maybe we did the problem wrong. Did we make a mistake somewhere? This is why we check it. It looks like we maybe made a mistake somewhere because I'm looking at how I wrote in that stuff. 7x minus 9 over x plus 3.
Why would it be?
We must have made a mistake somewhere. Unless am I seeing something wrong? Let's go back and see. P times P plus 3. That's correct. When I multiply it here, I get 7P plus 7P squared. Oh, I forgot the P here. I forgot to multiply in with the P. So that's actually 1P. See the mistake? You see what I did wrong?
Kind of.
I forgot when I multiplied the 7P. I multiplied 7P here.
Oh, okay. And then, okay.
I forgot about the P.
21.
Yeah, I was just being too quick. So subtract 6P from both sides. You're going to get 15P equals 45. Subtract 15 from both sides, you get 3. That will probably work. So now watch, you can just do 3 store X, and then you can arrow back up and you can get these things. Hit enter and plus arrow back up. Get, oops, nope, I didn't mean to do that. Clear. Arrow back up and just hit this. So I'm going to take my answer and then add that again, and I should get 7 this time, which I will.
So I have a quick question. On the test, on the unit test, we don't get calculators. So would it be worth it to go back and check my work after doing the problems?
If you're done with the whole thing, go ahead and just do it manually. Yeah. So take 3, like you can, a lot of the times you can just do it in your head, right? 15 divided by 3 is 5. You're like, okay, that's 5. And then plug in 3 here. 21 minus 9, that's 12 over 3 plus 3, 6. 12 over 6 is 2. 5 plus 2 is 7. Boom, it worked. Usually, if it's a non-calculator test, they don't give you 2 problems that are too difficult.
Okay.
All right.
Ready. Thank you.
Hey, no problem. Good job. And good luck tomorrow on that test.
Thank you.
All right. See you.